So, we were discussing about the 6 climatological cyclogenesis parameters. They are 3 dynamical and 3 thermodynamical parameters, which is sufficient and necessary for the formation of cyclogenesis. So, based on this, there are different cyclogenesis potential parameters developed by many scientists. So, of which one developed by Emmanuel. Emmanuel is a famous tropical meteorologist. He has done a lot of work in tropical cyclones. So he and his student Nolan, they developed a cyclogenesis parameters like this. And I am coming to that. Before that, I am just describing the Kotel cyclogenesis potential parameters, which is being operationally used by IMD for operational prediction. As we know that for the cyclones there are 3 dynamical parameters like sufficient low level vorticity, and then middle level humidity, and thermal instability, then which is inversely proportional to the shear, and then SST greater than 26 degrees Celsius. So combining all these 6 parameters, he has taken humidity index as mid tropospheric humidity index between 850 and 500 HPA, then mid tropospheric instability as difference between temperature between 850 and 500 HPA. So based on that, he developed a proposed cyclogenesis parameters known as genesis potential parameters. So naturally, on the numerator, all the positivity affecting correlated with the positive parameters, they comes, and shear will come in the denominator. So actually this is the simplest one of if you look at the Kotel parameter. He also put Emmanuel and Nolan, they put forward another parameter. This is eta is here, it is relative vorticity. Here they have taken absolute vorticity, which includes both earth rotation and vorticity due to relative motion, and then H is humidity index. He has taken as the humidity index is scaled according to this. Then Vpot, he defined the thermal instability defined based on this parameter. So this is known as Vmax, or potential intensity. Then here comes shear. It is bracket is not means visible here, but there is another minus comes, means it will be in the denominator. So these are the parameters. So based on this, these are the operationally used 2 cyclogenesis parameters. So if you look at we have studied the life cycle of thunderstorms, but here cyclone also has to go through different stages of development. So like if you look at, but only one difference is that if a thunderstorm forms, it will form, mature and decay by producing rain. So most of the thunderstorms, it goes through a kind of 3 stages of development. But in the case of depression or cyclonic storms, sometimes it will develop only up to 2 stages, then it will dissipate based on the favorable parameter. If any one of those cyclogenesis parameter which is unfavorable, then what happens is that cyclone will dissipate without going for further development or without going for next stages of development. So that means sometimes the tropical depression stage, disturbance stage itself, it will not disturbance may not develop into a cyclonic storms. Once if it is developed into a low pressure system or depression, which doesn't guarantee that it will further intensify into a cyclonic storm. All this depends on the ambient parameters, the cyclogenesis parameters which is considered, which we have discussed earlier. So the intensification means genesis, intensification and decay, everything is depending on many, not only inherent to the cyclone itself, the background, the environmental flow pattern, the SST, everything will be means affecting its life cycle. So what I want to say is that some cyclones will not, some cyclonic system will not go to after 2 stages of development, it will decay. So that means if you look at the full stages of cyclonics, if you want to have a highest intensity cyclonic storm like super cyclones, which is having wind speed of greater than 120 knots. So if it has to go to that stage, the cyclone has to go through at least 4 stages of development. First is formative stage, where which corresponding to something in between tropical disturbance to low pressure system. There should be at least one closed isobar in the synoptic chart like this. And then if it is going to a next level, it is a formative stage, the genesis stage, where you can find 1 or 2 closed isobar, but the minimum sea level pressure is not dropping below 1000 HPA. So that means it is not getting intensified. So here also there is chance that if conditions are unfavorable, cyclones, this system will dissipate their itself. So then that is known as immature stage. First is formative stage, then immature stage. If everything is favorable, then it will go for the next stage, that is known as mature stages of the cyclones. This time the center pressure will drop below 990, 980, so that the wind speed will be always greater than 64 knots. That is the typical characteristics of a cyclonic system. So this is the mature stage. And then after that also there is another stage, decaying stage. When cyclones decay is that if cyclone hit land, so it will decay. After hitting the land, it will go inside the land, because the main ingredient for the cyclone's development is the warm ocean surface. So once it hit land, the ocean surface there, which provides the energy, it is like a Carnot energy cycle. The cyclone is deriving energy from the warm water, so that there won't be much supply of energy once it is hitting land and moving inside land. And another thing is that means the thermodynamical ingredients will be cut off once it hits land. And also there is a lot of friction, that is surface drags, that means in terms of buildings, trees and all. Mechanically also there will be some kind of opposition to the cyclone, so that it will decay. So that is the decaying stage of a cyclone. So then this is very much I have described all these 4 stages. Then it's movement. So then another important characteristics regarding cyclone is the center portion of the cyclone, that is known as center portion of the cyclone. In a satellite image, if you look at, you can see that at the center there won't be much cloudiness, but if it is in a mature stage, there won't be much cloud at the center, but you can find a lot of spiraling cloud band. But this is the stage, this is the typical mature stage of the cyclones. All cyclones will not develop I. Once I is developed, means the cyclone will means become very strong and very in a mature stage. So this center portion is known as I. The diameter can vary from something like 50 kilometer to 100 kilometers, so the diameter varies like that. So this is outer cloud band, and inside the eye there won't be much cloudiness. So these are the characteristics of the eye which I have described here. And if you look at the outer portion of the cyclone, you can find that there is a wall type of cloud generation. So it is like that. It will cloud will develop in the not at the center, but away from the center at a distance of around 50 to 100 kilometers. So there will be tall clouds at this point. So there is a lot of updraft happening over here, and then outflow at the upper surface. If you look at the circulation pattern, you can find cyclonic circulation, that is wind turning anti-clockwise in the northern hemisphere at the surface. But if you look at the upper atmosphere, you can find that there is a large outflow. That means the circulation is anticyclonic. That means it will be called clockwise in the northern hemisphere. And if you look at the circulation pattern, there is an interesting patterns like that. There is updraft in the eye wall, and then some of the portion of this updraft circulation will coming as downdraft inside the eye. So that means this is how you can find in most of the cyclone you can find maximum heating in the middle troposphere. What is happening is that if air is lifted up means it will cool adiabatically, or it will cool according to thermodynamic laws. But if you in a downdraft, if air is coming from up, that means it will always compress, not expand, compress and get warmed up, so adiabatically warmed up. So that means two factors, and also there is lot of latent heat is being liberated at this level. So that's why most of the cyclone warm core is maximum at the middle level. And there is another reason why if you look at the center portion, there is a void of cloud at the center, at the eye. So it is because of if you put your hand in a bucket and rotate like this, you can find that there won't be much water at the center. Likewise the air is rotating very fast at the outer surface, and also there is along with that there is downdraft motion from the eye wall. So these two factors is limiting the formation of cloud formation, because there is large scale downdraft happening, because there is nothing no other mechanism to lift the parcel. So that is why the central portion of the eye parties of cannot be seen, means clouds are always absent in the eye. And sometimes you can find there is another secondary eye wall away from the primary eye wall. You can find secondary eye wall, and there is enough downdraft happening away from the cyclonic center. So this is the structure of the cyclonic circulation structure and eye wall structure. If you look at the wind profile, this is the center of the eye. This is the center of the cyclone, and eye wall is somewhere here away from the center, something in between 0 and 50 kilometers away from, is the eye wall. So you won't find the maximum wind speed or minimum you can find minimum drop in surface pressure you can find at the center, but the maximum wind speed always you can find at the eye wall. So this is because if you look, this is the wind profile, the unit is in the right hand side. You can find that the maximum wind you can find at the eye wall of the order of 150 km per hour. So and then wind speed decreases towards the eye, and again also decreases away from the eye. So and the minimum sea level pressure always decreases towards the center. So this is the structure of the sea level pressure and wind speed associated with the tropical cyclone. So this another thing is the vertical structure of we have studied the vertical structure of convective system, but there is another structure of the vertical structure of the cyclones also. There is a in lower level inflow layer where most of the cloud is means the moisture convergence is happening, means in the inflow where mostly the circulation is cyclonic. That means in the northern hemisphere it is anti-clockwise, and then the converging air will be lifted up where there in the lower level only you can find a horizontal convergence, and the middle level you won't find any kind of horizontal convergence. Instead you can find at the center lot of air is moving upwards. That means most of the upward motion you can find in the middle layer, and then the upper level all this air which is converging at the upper levels of the cloud system is diverging from the upper level. That is known as, that is always, if you look at the cyclone from satellite, the image from satellite, you can always find the spiraling cloud rotating like clockwise direction, that is anti-clockwise. That means you are looking, you are seeing the cyclone from the top, so that you won't find any cyclonic spiraling band. Instead you are finding anticyclonic spiraling. So that is the outflow. These are the vertical structure of tropical cyclone: inflow layer, middle layer upflow, and upper level outflow. And this is the typical structure associated with the cyclone, three-dimensional structure. And this also already I mentioned. If you look at the wind speed, it will be like this, the vertical variation of the wind speed. This is the center. And if you look at the temperature anomaly, as I said, the maximum temperature warming is you can find at the middle troposphere, not at the surface, not at the upper level. Rather you can find at the middle troposphere. So this is the this is the lower level. There are A, B, C, D, E. You can find the structure of the clouds at the point A is like this, very tall, and then B, very small clouds, very shallow, or cumulus, a simple low level cumulus cloud, and the around D you can find the spiraling cloud bands with the CBs, nimbostratus, cirrus, outflow, anvils, and all you can find. So this is the typical structure of the. Sometimes last year in the Arabian Sea, there were. It is very rare in actually. It is very rare in Arabian Sea. The Fujiwara effect. Fujiwara effect is nothing but if two cyclones comes together, form in a basin. This is very common in Western Pacific. You can find sometimes you can find up to 4 or 5 typhoons at a same time in the tropical Pacific, because the width of Pacific is very, very large. So that means the circulation of these two cyclones will interact with each other, and there will be at the center there will be a common point of interaction. That means it interacts like a dipole, and there is a common point of interaction, and mostly this interaction happens if two of this system comes closer below the distance between these two systems will be below 1200 kilometers, so that it will interact. This is very rare in Arabian Sea, because the width, if you consider the width of the Arabian Sea, it can only accommodate one cyclones. But last year in the pre-monsoon season there were 2 cyclones at the same time, so one was intensified into a super cyclone at the same time, another formed in the Arabian Sea. So that was the very, very, very rare system. So this is how the two systems interact when they comes closer. So these are regarding the tropical cyclones. I think we have completed the second modules, which tropical convection and tropical cyclones. So thank you.